Okay, so I'll be doing question number 33. And so the problem states an unstable atomic nucleus of mass 17 times 10 to the negative 27th kilograms initially at rest disintegrates into three particles. One of the particles of mass 5 times 10 to the negative 27th kilograms moves in the y direction with a speed of 6 times 10 to the 6 meters per second. Another particle of mass 8.4 times 10 to the negative 27 kilograms moves in the x direction with a speed of 4 times 10 to the 6 meters per second. Find A, the velocity of the third particle, and B, the total kinetic energy increase in the process. So I drew my diagram. So first I had the atomic nucleus at rest with the weight, and I showed the first one moving in the y direction, and I showed the second one moving in the x direction, and then I showed the third one that's unknown and what we're solving for. Then I began to solve the problem. So first I had to find the mass of the third one, and so that was pretty easy to find. You just add the other two that we know from the one at rest, and we get 3.6 times 10 to the negative 27 kilograms. And then from there we know that momentum is conserved, so we set it equal to 0, and since the velocity of the one at rest is 0 because it's at rest, this side's going to equal 0. And so we know that since the first particle is moving in the y direction, it has to have a j vector, and the one moving in the x direction has an I vector, and then this one just there. And then we set it equal to the third velocity that we're looking for, and we plug everything in, and we get negative 8.3 times 10 to the 6 j hat minus 9.3 times 10 to the 6 I hat. And we find the magnitude of that to get the speed, or to get the velocity, and we get 1.25 times 10 to the 7th meters per second. Then for part B, we find the kinetic energy using adding up all the different kinetic energies together for the first, second, and third particles, and we just plug that in, and then we find that it's 4.38 times 10 to the negative 13th joules.